Welcome to the fifth lecture on digital simulation. In this video, we will see the effect of adding a voltage controlled voltage source in the MNA matrix. In the previous video, we have seen how to add a current controlled voltage source in the network. Now we will see a voltage controlled voltage source. So the symbol of a voltage controlled voltage source is shown here. So this is the symbol. Here this voltage controlled voltage source is connected between node K and node L in the network. And since this is a dependent source, the magnitude of this source will depend on the some other voltage in the network. Since it is a voltage controlled source, its magnitude will depend upon some other voltage in the network. Here it is a voltage between nodes M and N. So here Vmn is a voltage between nodes M and N in the network, and this voltage will be controlling the magnitude of this dependent source, and here A is a parameter. Now we will see how to add this source in the modified nodal analysis. So from the network we can write from the dependent source symbol, we can see that VKL is a voltage across these two nodes, that is VKL, which is equal to A times Vmn. This is given by A times Vmn. So VKL is equal to A times Vmn, and VKL is nothing but Vk minus Vl, and Vmn is nothing but Vm minus Vn. Now by rearranging this, we will get one equation. So this equation will get added to the MNA matrix. So the MNA matrix, in the MNA matrix, one more row will get added due to this equation. There will be one more row. So the number of rows will increase by 1 in the coefficient matrix, in the system of equations in the MNA matrix. Then in this dependent source, in our previous analysis, we have seen that we will mark the current flowing through a voltage source as a variable. We will treat the current flowing through a voltage source as a variable. So here also the current flowing through this dependent source will be treated as a variable. So this is IV denoted as IVKL, since it is between kth node and lth node, and due to a voltage source, we will name this current as IVKL. So one more variable is added to the variable vector. So our number of columns will also increase by 1. So the number of variables increases by 1 due to voltage controlled voltage source. So the number of columns will be increased by 1 corresponding to this IVKL. Then this dependent source introduces one more equation into the system. So the number of rows will also increase. So if you incorporate this equation into the matrix, we can see that this A is multiplied with Vm. So on the mth column, this A will appear, and here minus A is multiplied with Vn. So in the nth column of A matrix, minus A will appear, and Vk is multiplied by minus 1. So on the kth column, there will be a minus 1 entry, and Vl is multiplied by positive 1. So on the lth column, you have plus 1. So in the additional row corresponding to IVKL, we will have these 4 entries, A, minus 1 and 1 on these columns Mn and Kl. Then from the circuit diagram, we can see that on the kth node there is an outgoing current IVKL, and on the lth node there is an incoming current IVKL. So on the kth node, IVKL is going out. So there will be a plus 1 on the kth node or on the kth row, and on the lth node IVKL is coming in. So on the lth row you will have a minus 1. So this is the stamp of a voltage controlled voltage source. So to the original A matrix, you add one more row and one more column, and in the additional column, you will have a +1 and -1 on the kth row and lth rows. And on the additional row, you will have A, -1 and 1 in the location, in these locations, mth column, nth column, kth column and lth column. So this looks slightly complicated, but we can make it clear by doing an example. So this is a very simple example to illustrate the concept. So here we have an independent source. So this is an independent source, independent voltage source, and here we have a dependent voltage source. So this magnitude of this dependent voltage source depends on Vx. Vx is a voltage in the network. It's another voltage in the network. So it is a voltage controlled voltage source. So it is a voltage source and its magnitude is controlled by another voltage. So it is a voltage controlled voltage source. So in MNA analysis, the first step is identifying the number of nodes. So here, this is our first node, and this is our second node, and this one is our third node, and this is our reference, 0. So we have 3 nodes in the network, so we can write 3 KCL equations. And what are the variables in the MNA matrix? Since there are 3 nodes, first we can write the variable matrix X. Since we have 3 nodes, V1, V2, V3 are the 3 variables corresponding to the node voltage. And since we have an independent voltage source, a current flowing through the independent voltage source. So suppose IV1 is the current flowing through this 12 volt source, then IV1 will be one more variable. Then IV2 will be the current. Suppose IV2 is the current flowing through this dependent source, then that will be the second another variable. So totally there are 5 variables, 3 voltages and 2 currents. And the direction of currents should be marked in this way, since we are following the convention from plus to minus. We will mark the direction of currents from plus to minus. So here it will be from top to bottom. Here it is from plus to minus, so it is from bottom to top. Now we can write the KCL equations. So let me copy this circuit. So let us start with the node 1. In node 1, IV1 is coming out. So IV1 plus current flowing through this 2 ohm is V1 minus V2 by 2. So this is equal to 0. So our first equation will be plus half V1 minus half V2 plus IV1 equal to 0. This is our first equation. Now let us write the KCL at node 2. So at node 2, current flowing out from node 2 through this 2 ohm is V2 minus V1 by 2. Current flowing through the 6 ohm in this direction is V2 minus V3 by 6. Sum of the outgoing currents is equal to 0. So there are 2 currents flowing out. The algebraic sum is 0. So on simplification, we can write minus half V1 plus 1 by 2 plus 1 by 6. So it will be 8 by 12 or 2 by 3 V2 minus 1 by 6 V3 equal to 0. So this is our second equation. Now we can write node 3. KCL at node 3. So node 3, current flowing through the 6 ohm is V3 minus V2 by 6. Then current flowing through this dependent source, current flowing away from node 3 through this dependent source is IV2. But IV2 we have assumed in the top upward direction, so it is minus IV2. equal to 0. So that is third equation. So minus 1 by 6 V2 plus 1 by 6 V3 minus I V2 equal to 0. So this is third equation. So we got three KCL equations. Now we can write two more equations by looking at the circuit. What is V1? From the network you can easily see that V1 is nothing but 12 volt, because between node 1 and ground or reference node 12 volt is connected. So V1 is 12 volt. So that is our fourth equation. Now one more equation we can write V3. V3 is nothing but this voltage minus 2Vx, minus 2Vx. So V3 is minus 2Vx. But what is Vx? Vx, from the network you can see that Vx is voltage between node 2 and ground. So it is V2. It is simply V2. So V3 minus 2 V3 is equal to minus 2V2, or we can write 2V2 plus V3 equal to 0. So this is our fifth equation. So let us list out all the equations. First one is this. This is first equation. Second equation is this one. Third equation is, sorry, second equation was this one. Okay, third equation is written here. Now fourth equation is this one, V1 equal to 12. Fifth equation is 2V2 plus V3 equal to 0. So now let us write it in matrix form. So coefficient matrix multiplied by V1, V2, V3, IV1, IV2 equal to right hand side. So our first equation is this one, minus half V1, sorry, plus half V1 minus half V2, 0 V3 plus IV1 plus 0 IV2 equal to 0. So that is first equation. Second equation is minus half V1 minus half V1 plus 2 by 3 V2 plus minus 1 by 6 V3 plus 0 IV1 plus 0 IV2 equal to 0. This is equal to 0. So this one was equal to 0. Then on the third equation we have minus, there is no coefficient for V1, so this is 0. Coefficient of V2 is minus 1 by 6. Coefficient of V2 is minus 1 by 6. So V3 coefficient is 1 by 6. IV1 there is 0. For IV2 it is minus 1. Then coming to fourth equation, that is V1 equal to 12. So it is 1, 0, 0, 0 equal to 12. Then on the last equation, that is 2V2 plus V3 equal to 0. So we got all the equations. Now let us check whether we can write this equation directly by inspection. So for that, let us partition this A matrix into G, B, C, D. So what will be the size of G matrix? G matrix will be number of nodes by number of nodes. There are 3 nodes, so it is 3 by 3. So let us partition it. So this first 3 by 3 matrix will be G matrix. Then this part will be our B matrix. This part will be our C matrix. This one will be our D matrix. So from our theory, we know that addition of a dependent source, addition of this voltage controlled voltage source increases the size of the system by one column and one row. So this is the additional row that is introduced, and this is the additional column that is introduced. This one is the additional column that is introduced. So let us check whether we can write this system directly. So for that purpose, let us copy the diagram once again. And let us write the matrix by inspection directly. So it is a 5 by 5 matrix. A matrix is a 5 by 5 matrix. Within that, we have a 3 by 3 part corresponding to our G matrix. So G matrix will have 3 columns and 3 rows. So what are the entries? So G matrix. First diagonal entry will be sum of elements connected to node 1. That is simply 1 by 2 because only 2 ohm is connected to node 1. Then second diagonal entry to second row, second column is add the reciprocals of resistances connected to node 2. 2 ohm and 6 ohm are connected to node 2. So 1 by 2 plus 1 by 6 is 2 by 3. Then on the third diagonal position, add the reciprocal of resistance connected to node 3. It is simply 1 by 6. So we got the diagonal entries. Then off diagonal entry between first node and the second node. 2 ohm is connected, so negative of reciprocal minus half. Then between first node and third node nothing is connected, so 0. Between second and third it is 6, so it is minus 1 by 6 here. So here it is between second node and first node it is minus half. Between third and first it is 0. Between third and the second it is minus 1 by 6. So we got the entries of G matrix. Let us cross check it with the previous one. So you can see that the same is coming here. Now coming to the, so this completes our G matrix. Coming to the B matrix. Inside the B matrix you have column corresponding to the first 12 volt dependent source or IV1, and you have the column corresponding to the second dependent source IV2. So the first source is connected between node 1 and ground. So put a 1 positive terminal of the source is connected to node 1. So put 1 on first row, and negative terminal of the source is connected to ground. So minus 1 is not needed since it is at a reference. So 1, 0, 0 are the entries corresponding to the first independent source. Then corresponding to the second voltage source, this minus negative plate is connected to node 3. So you have a minus 1 on the row 3. Then the positive plate is connected to reference, so there is no plus 1. Okay, so these are the entries of B matrix. Now coming to the C matrix, this 1, 0, 0 will be transposed because since it is due to the independent source, it will directly appear here. Then for the second source, since it is a dependent source, we have to fill it carefully. For the dependent source, we know that from our theory, we know that we will have A and minus A coming on the mth node and nth node, and minus 1 and plus 1 coming on the kth node and lth node. So in our case, what are the mth node and nth node? M, N, K, L. Here dependent source is connected between node 3 and ground. So K, positive terminal of the dependent source is connected to reference. Negative terminal of the dependent source is connected to third node. Then it depends on Vx, where Vx, positive terminal of Vx is connected to node 2. Negative terminal of Vx is connected to node 0. So M is 2 and L is 3. So entries will be coming only on 2 and 3. For reference, you need not put any entries. So m is 2. So on the mth column, we have to enter the value of this parameter. So mth node is second node. So on the second column, you will have a 2, this parameter a. Similarly, on the lth node, you have to put 1, because from our theory you can see that on the lth node you have to put a 1. Okay, so here the lth node is third node, so on the third column you have to put 1. So this entry is 0. The other entries are zeros, and the D matrix is a 2 by 2 0 matrix. Since we have two sources, two voltage sources, it will be of size 2 by 2 and the entries are zeros. So like this you can fill the A matrix, and the coefficient and the variable matrix is V1, V2, V3 node voltages and currents through the voltage sources. And on the right hand side entries are the independent current sources coming here. So first 3 entries corresponding to the voltages will be the independent current sources coming to the first 3 nodes. There are no independent current sources in the network, so the first 3 entries will be zeros. Then corresponding to this IV1 and IV2, we have to put the magnitude of the sources. IV1 is due to this independent source 12 volt, so simply put 12 here. And IV2 is due to this dependent source, so there will not be any entry, it will be 0. So this is how we can fill the matrix by inspection. Let us now solve this system of linear equations using MATLAB. So open MATLAB, and in the command window, we can enter the values in the A matrix. So each row is separated by semicolons. You can enter the values within the square brackets. Each row is separated by semicolons. So this is A matrix. Then you can enter the value of the right hand side column vector, that is Z is equal to 0, 0, 0, 12, 0. Okay, so once you have entered the A matrix and the right hand side column vector, you can get the solution. X is equal to A slash Z. So the solution is 12, 6, minus 12, minus 3, minus 3. So our V1 is 12, V2 is 6, V3 is minus 12, and the two currents IV1 and IV2 both are equal to minus 3. So let us write it here. So the solution is V1 equal to 12 volt, V2 equal to 6 volt, V3 equal to minus 12. Let me check. V1 12, V2 6, V3 minus 12, IV1 equal to minus 3 ampere, IV2 equal to minus 3 ampere. Okay, so the current flowing through the 12 volt independent source is minus 3 ampere. So we have assumed the direction of current downwards, minus 3 ampere downwards or 3 ampere upwards. So this will be 3 ampere this way. So current flowing through 2 ohm will be 3 ampere, and the same current is flowing through 6 ohm. So the question was, write the MNA equations and calculate the current through 2 ohm. So the current through 2 ohm is 3 ampere. So we will stop it here, and we'll continue in the next video. Thank you.